So it's final exam review, and the worksheet that I posted is an old final exam worksheet for when I gave a 33 question final exam in class. But since we're doing this in quarantine and online and that stuff, I cut it down to 18 questions, and I cut it down to just these 5 topics that you have to focus on, which is great because, the first 12 questions on this worksheet are all about equations, and there are no equations. So we can skip that stuff. But there are inequalities, and so we're going to start with number 13. Now, specifically, we're going to look at linear and absolute value inequalities, which I think is all they have on there. So we start with 5 minus 3x greater than 26. Now, the idea here is that all of our answers should be in interval notation. So when we finish, we're going to have to graph it on a number line to figure out what the interval notation is. Anyway, when we get to inequalities, basically we just solve it like it's an equation. So I would say minus 5 first, negative 3x greater than 21. And then I'm going to divide by negative 3. Now, the only time I flip this guy is when I divide by a negative 3. So when that cancels, that flips, and this is negative 7. All right, so drawing the number line, the only number that I care about is negative 7. It's somewhere on the left, so I'm going to put it like this. And then it's a left arrow, so I'm going to draw that on above a tub. And then since there's no line underneath, I'm going to draw parentheses right there. The number on the left side of the number line is negative infinity, so when I write this in interval notation, it's going to be negative infinity to negative 7 with parentheses. Right. Number 14. So with number 14, let me get some shadow issues here. There we go, a little better. We have an absolute value inequality. So the idea is that when we have an absolute value inequality, we want to get the absolute value by itself, it is, and then we want to split it up into 2 using KFC. Let's keep it the same for the first guy, so there you go, x minus 4 less than 3. But then for the second guy, we're going to flip this, or actually, KFC actually goes for the second guy. The first guy is always the same. But the second guy, you're going to keep x minus 4 the same. You're going to flip this to greater than, and you're going to change this to negative 3. Does that make sense? Why am I asking? Okay. And then we add 4 on both of them, and we get x is less than 7. Add 4, and we get x is greater than 1, because different signs mean subtract. Okay. Number line. We have 2 numbers, 1 and 7. 1 is on the left side of 7. And then I go, okay, if it's less than 7, it's pointing to the left, like so. And if it's greater than 1, it's pointing to the right from 1. Well, there's overlap, right? So that's my answer. I'm going to use parentheses because there's no line underneath. So the answer here is just going to be 1 to 7. And that's the thing for absolute value. If there's overlap, that's your answer. That's how you do absolute value inequalities. And just do another one. 2x plus 3, absolute value, and that's greater than or equal to 5. All right, so we're going to split it up. First one is the same, 2x plus 3 greater than or equal to 5. And then the second one, you're going to keep 2x plus 3. You're going to flip less than or equal to, and then you're going to change it to negative 5. Okay, so we subtract 3 on both sides. We get 2x greater than or equal to 2. And we divide by 2, and we get x greater than or equal to 1, right? Nothing flips here because this is not negative. All right, minus 3, we get 2x less than or equal to negative 8. And then we divide by 2, we get x is less than or equal to negative 4. Again, don't change the sign, the inequality sign. So we got 2 numbers that we care about, 1 and negative 4. Negative 4 is on the left, 1 is on the right. And then we say, okay, at 1, we're going to the right. And since there's a line underneath it, we're going to use a bracket. At negative 4, we're going to the left. And again, bracket. So here, there's no overlap. And if there's no overlap, then you're going to need to include both of these intervals in your answer. So negative infinity to negative 4, the bracket at negative 4 and parentheses at infinity. And then you need bracket 1 comma infinity, and then you're going to connect them with a little u. Right. And that's one example of each one of those. I'm trying to remember if there is a fraction one. I don't think there is. There's not a fraction one on the inequality world. So I figure that's 3 good examples of those that you can look at. And we can jump right over to graphs, which this particular exam worksheet was made before we changed some of the requirements for your final exam. So now we want to make sure that everybody understands how to graph lines in intermediate algebra. And that was one of the things we cared about, but it wasn't super important. We only had like 1 question. So that's why the exam review worksheet only has 1 question. But you have 3 questions on the final exam about graphing. So we need to kind of look at this a little more extensively, especially, we'll get there. So this is a general form. And what we talked about was the idea of creating an X and a Y table and then going, okay, let's plug in 3 random numbers for X and see what we get for Y. So for 0, we get 6 times 0 minus 7y equal to 42. That means he goes away. Negative 7y equal to 42. And then when we divide by negative 7, we get negative 6, right? 42 divided by negative 7 is negative 6. So that's the y value that goes with him. And then we start all over. We go, okay, what about 6 times 1 minus 7y equal to 42? And so here we subtract 6, right? This is 6 times 1 is 6. So I would say minus 6 on both sides to get negative 7y equal to 36. And then divide by negative 7, and that doesn't go very evenly. It's about negative 5 and 1/7. So it's around negative 5 when I graph it. Yeah, this isn't great, but it's the way I had taught you. And then one last one, we're going to say 6 times 2 is 12. And then I'm going to subtract 12 from both sides. And that gives me 30. And then when I divide by negative 7 goes into there negative 4 times with about 2/7 left over. So it's around negative 4. So the idea here is that if I were to graph this on an XY plane, then 0, negative 6, I would go down 1, 2, 3, 4, 5, 6, put a point. And then at 1, I would go down to about 1, 2, 3, 4, 5, and then just a little bit scotch more. And then for 2, I would go down to 4, and then a little bit more. So just around negative 4. So the graph looks like this. Now this is just one way to do it. There's another way to do it, which is where we use intercepts. So just as a separate thing, intercepts. You plug in 0 for one of the letters. This works really well for general form. So here, if I did that, I did that once. I had 6 times 0 minus 7y equal to 42. That gives me, y equal to negative 6. We did that. But the other one, if we said 6x minus 7 times 0 equal to 42, this will tell me the x-intercept. So 6x equal to 42, right? That goes away. And then if I divide by 6, I get x is equal to just 7. So if I graph this, 1, 2, 3, 4, 5, 6, 7, it's going to go through the x-intercept right here at 7, 0. And we have 0, negative 6. And that's another way to graph this. You just need 2 points there. You're not dealing with fractions. That makes sense? So that's why I like intercepts for general form. And you can use that whenever you do the general form on the quiz. I'm going to say 20.5 because this isn't on your review worksheet, but I do want to give you an example. So y equal to 2. So this is weird because it's not a regular line. It's actually a horizontal line. Now, here's the thing I have to remember is that horizontal lines, which look like this, by the way, just for make sure you understand that, are always y equal to a number when you write out the equation. So since this is y equal to 2, we're going to go up to 2 on the y-axis, and we're going to draw a horizontal line. And that is all there is to this. So the other thing you need to know is vertical lines, which is the other weird type of line, which is up and down. But their equations always are x equal to number. So if you see x equal to a number, then you're going to draw a vertical line at that number on the x-axis. Okay, it's just a little helpful thing there. The last type of thing is called the slope-intercept form, where if you have y is equal to 1/3 x plus 2, and just separate this and call this 20.9. I don't know. You know, it's just, whatever. So y equal to 1/3 x plus 2. In this case, you could do the same thing we did up here where we set up an xy table like this and just plug in 0, 1, and 2. But because there's a fraction next to here, what I would do is I would plug in multiples of 3. So I would go 0, 3, and 6. And the reason why I do that is because when I multiply 1/3 times 0, it goes away. The fraction goes away. I'm just left with 2. Right? That goes away. When I multiply 1/3 times 3, this actually becomes 3/3, which is 1. So I have no fractions. And that's why I'm picking multiples of 3, because of that denominator. I'll create answers that aren't fractions. So this would become 6/3, and that's 2, sorry, plus 2, that's 4. Right? So for those 3 points, I would, graph the xy plane, 0, 2, which is up 2, and then 3, 3, 1, 2, 3, and up 3, so there's this point, and then 4, 5, 6, and 4, and the graph looks like this. So that's how you can graph with slope-intercept form. That's how you graph a horizontal and vertical line. This one's the one I'm dealing with. And then this one is how you deal with general form. I prefer intercepts because you never know if you're going to get fractions going this route. But this route for slope-intercept form is great, as long as you pick multiples of this denominator. Now, if there's no fraction, you can just pick 0, 1, 2. It's fine. All right. That's graphing. All right, let's go to the next section. Factoring, there's no factoring, so we don't have to do 21 through 26. So we start at 27, because 27 deals with exponents. And the first thing here is we have negative 10a, b to the fourth, and then negative 2a to the third, b to the sixth, all raised to the second. So when we're dealing with the laws of exponents, we want to deal with outside powers first. And then we want to do any of the other rules. And so we can do the product rule, quotient rule, product or quotient rule. And then we can deal with negative exponents after that. I like to deal with negative exponents last, but if it's an outside power and it's negative, don't flip. Just go ahead and multiply, as you need to. So here's the outside power that I have to deal with first. So forget about him. Let's just leave him the same. Don't do anything to him. But this 2 goes on him, and it goes on him, and it goes on him. That's what an outside power rule is all about. So we have negative 2 squared, which is negative 2 times negative 2. That's positive 4, right? 2 negatives make a positive. And then we have a power raised to a power, which means we multiply them. 3 times 2 is 6. 6 times 2 is 12. Now we can do product rule, which says that you can multiply the numbers in front together, and then you add exponents. So 6 plus 1 for A, and 4 plus 12 for B. And there you go. And let's see, 28 is a bit more complicated than what you'll see on the quiz. And 29 is fraction exponents, and there are no fraction exponents. So let's skip to 30, which is something you will see, very similar, except without negative exponents, actually, in the problem I gave you. you know, try to make it doable. Since I can't be there helping you before the test, best I can do is create this video. Okay, so here we have a quotient rule, no outside power. So if I dealt with quotient rule right now, I would kind of separate these out into their different parts. So negative 48 over 32. 32 doesn't go evenly, but I can divide an 8, I think. 8. Actually, I can divide a 16, can I, to reduce this? So negative 3, and then 32 divided by 16 is 2. Now, if you didn't think of 16, it's okay. You can divide by 2 and get 24 and 16, and then go, oh, I can divide by 2 again and get 12 and 8, and then I go, oh, I can divide by 2 again and get 6 and 4, and then, oh, I can do 2 again and get 3 and 2. So just keep going with the numbers you know go into both until you get down to the lowest 2 numbers. All right, that's fraction business. X's. Now, for x, it's going to be negative 3, the top number, minus the bottom number. And that means that I'm going to have a minus minus going on, which is plus, right? For y, top number minus the bottom number. Again, negative 2 minus minus becomes plus. And then for this, you're going to say z to the 1 minus 8. Okay? So this is just me doing the quotient rule. Now, if you don't like doing this, if you don't like dealing with subtracting with negatives and all that stuff, you could do the negative exponent rule before the quotient rule. And in that case, you would have, this would come up and this would come down. This would come up next to him, and you would add, and nothing would happen here. You'd still do what you're doing here. Anyway, I'm going this route, though, so bear with me. Negative 3 plus 1, different sign, subtract. So we're left with x to the negative 2. 5 plus 2, both positive, so we add, get 7. And then 1 minus 8, you subtract, so you get negative 7, and the larger number keeps the sign, All right, so that just means the last thing to do is negative exponents. This guy's going to come down. This guy's going to come down. He's going to stay where he is, and he's going to stay where they are. So we get negative 3 up top. Y to the 7th is still up top. 2 is down here, but now so is x squared, and now so is z to the 7th. So this is a much more complicated version than the one that you'll see on the final exam because they have negative exponents in the original problem. Now, you'll see something maybe like the z's, where they're both positive to begin with, but you'll get a negative answer, and then it'll have to come down. All right, no fraction exponents. Let's look at 33. This is radicals. So with radicals, 36, y to the 6th. Can't see this morning. X to the 10th. With a square root like this, in a fraction, you're just going to take the square root of the top and square root of the bottom. So it's going to look like this. And square root of the bottom. And for numbers, you know how to do that. It's what number times itself gives you 36. And for letters, you're going to divide the exponent by 2, or whatever the number is out here if it's not 2. So we get 6y to the 3rd, and we get x to the 5th, and there's no more square roots. So what if they don't divide by 2? What if they're like 5 or 11? Then you're going to have a square root left over. Does that make sense? You say, how many times does it go evenly? That's the number on the outside, and then whatever's left over is what's on the inside. I don't think I did that to you, but, just in case. All right. No scientific notation, so we're not doing that. We're not dealing with polynomials on the final. We are dealing with rationals where we add, so let's jump to 46. So these are the fractions. This is like a good bit of the quiz, the final. So this one definitely you should look at. So here we have 2 fractions, and the denominators are completely factored, linear factors. And you should put parentheses around them. You should. If they're different things, then what you're going to do is you're going to multiply them together for the LCD. So x minus 2 and x plus 1 are the new denominator. And then you're going to cross multiply to get your new numerator. So we've got 3 times x plus 1. And by the way, because it's going up, you start with the 3. It's important, because when you put the minus there, and then 4 times x minus 2, this is the correct order. If you switch the order, you're going to get the wrong sign in your answer. Okay. What you don't want to do here is cancel. Do not cancel. No cancel. Instead, you're going to distribute and combine in the top. So 3x plus 3 minus 4x plus 8, right? Two negatives make a positive, over blah, blah, blah. Don't care. And then I'm going to combine 3x minus 4x is negative x, and then 3 plus 8 is 11. And now I'm going to put that denominator in there. And nothing cancels. So that's how you'll deal with two fractions being added or subtracted where the denominators are not the same, but they're linear factors like this. All right? 47 is a multiply problem. And this is the one where you want to factor. So if you need to do some of those factoring problems to get some practice in factoring before you tackle this problem, which is more like something you'll see on the final exam, then you should do that. You should go back to, what numbers? Factoring, 21 through 26. There's a few factoring problems to get you warmed up. But this one, you're going to look at each part and factor them according to the way they should be factored. So this is a trinomial. And if I use a little x method, I got negative 10 up here and 24 down here. And I go, what two numbers multiply to give me 24 and add to give me negative 10? Negative 6, negative 4. So this becomes x minus 6 and x minus 4 up top. All right? That goes for him. And then I'm going to do it again for the bottom, because the bottom is also 3 terms. So I got negative 1 up there, negative 12 down there. And I go, what two numbers multiply to give me negative 12 and subtract to give me negative 1? And that's negative 4 and positive 3. So I'm going to have x minus 4 and x plus 3. Over here, so that goes to him. Over here, I've got 2 terms. And so the only thing I can do for this is difference of squares, which it is not, or GCF. And that's what I'm going to do there. I'm going to x, and then I'm going to divide each one by x to get x plus 6. Now down here's 2 terms, and they are difference of squares, so that's going to be the plus minus thing, x plus 6, x minus 6. All right, so it's fully factored now, and I can go around and cancel some factors. So x plus 6's will cancel, x minus 4's will cancel, and this one and this one, because one's up top and one's in the bottom, the x minus 6's will cancel. So all that's left is this guy in the numerator and this guy in the denominator. That is the answer. Okay. All right. Let's look at, see, there's no divide problem. So let's look at, there's no complexes. Well, let's just look at number 48. That one's another type of add subtract problem that might be on the final exam. I can't quite remember. But you have x over x squared minus 16 minus 3 over x squared plus 5x plus 4. So in this case, they're not linear factors. They actually can be factored. So what I'm going to do is I'm going to factor them right below. This is difference of squares, so we get x plus 4, x minus 4. So don't need that anymore. And then this is a trinomial where I say what two numbers multiply to give me 4 and add to give me 5, and that's x plus 4 and x plus 1. Don't need that anymore, okay? All right, so the LCD, the new denominator, is going to be everything from the first one, so x plus 4, x minus 4, and then anything new from the second one. So x plus 4 is already there, but x plus 1 needs to get put in there. All right, there's your LCD. And that's the way it goes with when you factor everything from the first one and then anything new in the second one. All go together, being multiplied. Now the cross multiply thing that I did before worked great whenever I didn't have any common factors, but I do have a common factor. So what I'm going to do is I'm going to cross through them. I don't need common factors when I cross multiply. I just need factors that aren't common. So again, it's pointed up and it matters. So start with x and then put x plus 1 next to it because those are the two being multiplied. And then the minus from him. And then 3 and then x minus 4 that goes with him. And again, do not cancel, just like before. Leave that alone. Let's just distribute and combine like terms, okay? So we get x squared plus x minus 3x plus 12 over blah, blah, blah. And then these two will combine to give me x squared minus 2x plus 12 over my LCD, x plus 4, x minus 4, x plus 1. All right, and that would be where I would stop normally. No, that is where I'm going to stop today as well. Sorry. I was like, ugh. The thing is, if this factors and one of those factors cancels with one of these, then you should do that. But this doesn't factor. And I don't think I put one on there where it does and, you know, tricking you or anything like that. All right. So let's go to radicals again. Let's jump down to something like 55. So this is, I know, something that looks very similar to what's on the final exam, so that's why I'm doing this. And I'm skipping around because I don't want this to be too long, oops, of a video, because you know you have from today to Thursday to do this exam. All right, so when we have two radicals being multiplied together, you can multiply this stuff underneath. So under one big house. So 6 times 3 is 18. 8 to the third times a to the first, you're going to add and get a to the fourth. B to the first times b to the seventh, you're going to add to get b to the eighth. And then you're going to be left with a c. Okay? So that's multiplying them all together and getting this. Now, when I want to simplify this, I want to split it up. Square root of 18, square root of a to the fourth, square root of b to the eighth, and square root of c, right? They all get their own little house. And the reason why I'm doing this is because each one of them could simplify. Now he doesn't, he's gonna stay the way he is. But this guy splits up into square root of 9 times square root of 2. And the reason why I'm doing that is because he's a perfect square and he can be worked on. Square root of 9 is 3. Square root of 2 stays the same, right? Square root of a to the fourth, remember we divide by 2 and we get a squared. Again, for b to the eighth, we divide by 2, we get b to the fourth, and then he stays the same. Okay? So all the outside stuff gets put together. 3a squared, b to the fourth, and all the inside stuff, 2 and c, get put together to make your answer. Okay? So definitely take a look at that one. 57 asks you to do FOIL with square roots. And I know there's one on the final like this. 56 is the distributive property one, which you might want to try doing with an example just because it's good practice. But this one I know is on there. So when we FOIL, it's first 6 times 4 is 24. Outside, 6 times negative square root of x is negative 6 square roots of x. Notice I cannot multiply 6 and x together. One's on the outside, one's on the inside. And then inside, same deal, negative 4 square root of x. And then the last, negative times negative is a positive, and then x times x is x squared. Right? So that's FOIL. And then I look and see, wait, these can be added together. They're the same sign, and they have the same radical. So I can add the outside numbers. 6 plus 4 is 10. Leave square root of x the way he is. This guy, the square root and the square, you're going to divide 2 by 2 and get x to the first. And that is the final answer for that kind of problem. Now this is sort of preparing you for a rationalized problem, more like 59, which I know is what you see on the final exam, something similar. So when you ask to rationalize, so here you can see times, that's what you're supposed to do, multiply. And this is a multiply problem as well. With rationalize, it's not telling you what to do. you have to remember what to do. And rationalize just means multiply top and bottom by the conjugate. And if you want to look in your notes for conjugate, you can, or I can just tell you it's the same terms but change this sign. So put it in parentheses first of all. And then we're going to say square root of x and 7, but we're going to put a minus sign in front, in between, sorry. Right? Change the sign. And then top and bottom have to be the same, so just write it again, like so. And then we'll go straight across, because when we multiply fractions, we're going straight across. So distribute, we get 5 square roots of x minus 35 up top. And then in the bottom, we're going to FOIL like we just did. So square root of x times square root of x is square root of x squared. Negative 7 square roots of x, which you get for O. Positive, sorry, this looks like a minus sign. I should probably put a dot or something, you know, whatever. Positive 7 square roots of x for I, and then minus 49 for last. Nothing to do up here. This is a square root, this is not, so they don't combine. So we're just going to rewrite it. 5 square roots of x minus 35, like so. And then down here, look at that. Negative, positive, they cancel each other. And this guy comes out as x. And that's the answer. Okay, so to make sure we did this, we talked about exponents with no fraction exponents. You don't have to worry about that. We did inequalities, linear and absolute value. We did rationals. We added, subtracted, multiplied. There's no dividing. There's no complex. We did radicals where we multiply and simplify, right? And we also did a FOIL problem. We did a divide radical problem, right, number 33. And then we also did graphing, right? Talked about the 3 ways that you graph. And I think that should take care of it.